Good morning, grade 12. This is our lesson for Tuesday, May the 12th. And today, as you can see behind me, we're going to look at electric circuits. I'm going to give you a lot of information today, but no homework. But before we get into that, let me give you our verse of the day today. It comes from Colossians 3, verse 17. It says, "And whatever you do, whether in word or deed, do it all in the name of the Lord Jesus, giving thanks to God the Father through him." So again, whatever you do it in the name of the Lord Jesus and give thanks through him. And so just something to meditate on and think about as you go through your day today. All right, electric circuits. You are all somewhat familiar with electric circuits since you use them every single day. Every time you turn on a light, every time you blow your hair with a hairdryer or make toast in the morning, you are making use of an electric circuit. And there are things called circuit diagrams, which we are going to get really good at drawing. And there are a couple of symbols that we are going to use to draw electric circuits. And we're just going to draw some key ones here on the board now, some symbols that we're going to use. And so the first thing is that we have a long bar and a short bar. This is a cell, otherwise known as a battery or some source of electric potential. All right, some source of, I'm going to put V for voltage, which stands for electric potential. All right, so, and the large bar is a positive terminal and the short bar is the negative terminal. All right, so it's some source of electric potential. Typically when we draw them, we'll draw them like this. We may add a couple of more cells to it. Doesn't matter how many are drawn. And accompanying it will be a number. 12 volts, 24 volts, 120 volts, whatever it might be. It'll be written in there along with the cell telling you what the potential difference is. All right. Then we are going to have resistors. Now resistors, and we're going to talk more about resistors in the next couple of days, but a resistor is anything that uses electric energy. So your toaster, your lights, computer, your clock radio, whatever it is, anything that uses electric energy is a resistor. Okay, a resistor slows the flow of the electrons, using some of that electrical energy, turning it into heat, light, whatever it might be. That is what a resistor is. The symbol for a resistor is simply a squiggly line. And again, the number of squiggles is irrelevant. It is just some squiggles up and down. All right. Now, there are diagrams, there are symbols for specific resistors, but we're not going to worry about them. So there is a symbol for a light bulb, for instance, but we're not going to worry about it. Okay, everything that uses electrical energy is a resistor, and that's what we're going to use. Now, a couple other symbols that we'll see is we may see something with a circle with a V inside of it. Okay, so that will be a voltmeter. Okay. A voltmeter is, again, just a meter that measures the potential difference that is passing through either a resistor or a circuit of some kind. All right, and finally, the other one we're going to see regularly is a circle with an A in it, and that is an ammeter. And an ammeter measures the amount of amps that are flowing through a circuit, so it measures current. All right, so those are the symbols we're going to use. A typical circuit then might look something like this. I drew that wrong. Let's do it this way. Okay, we're going to have short line, long line. So here I've got a source of electric potential, a wire coming out of it. We put a resistor here. Let's put a resistor here. And one more here. Okay. And the key point here is that, A, it's got to be a circuit, okay? It's got to be a complete closed loop, okay? And it doesn't have to be a rectangle or a square. It can be any shape. Whatever shape you can put your wires in is what this will be. We will typically draw rectangles and squares and those kinds of things just because it's easier, but the shape is irrelevant. Now, if we were to look at this and say, which way does the current flow in this? Well, current, okay, not the electrons, but current would flow in this direction, okay? So again, current, which is the symbol I, flows away from the positive terminal towards the negative terminal, okay? Because remember that current is the opposite direction of electron flow. And if we were looking at the electrons would go the opposite direction because electrons would be repelled from the negative pole and attracted to the positive pole, right? So electrons go this way in this case, current goes this way. All right, so again, current will flow from the positive to the negative. All right. Now, there are two kinds of circuits. There's a circuit like this, which is called a series circuit. Okay, so this is a series circuit, S-E-R-I-E-S. Okay, a series circuit. Okay, and then there are parallel circuits, and parallel circuits look something like this. Okay, and the difference here is that in a series circuit, there is only one path for the electrons to flow. They start here, flow around the circuit, end up back at the potential difference. Here, in a parallel circuit, there's only one R in parallel circuit. In a parallel circuit, now there's multiple options, right? The current's going to come out here, and then part of it will go up here, part of it will go this way, and then it will come back and it'll join together again and come back there. All right, so series, one path, one thing, one way for the electrons to flow, parallel, multiple options, okay? Now, a scientist by the name of Kirchhoff, okay, Kirchhoff was studying this and he asked two questions. He asked the questions, what governs the amount of energy that is used up in each resistor in a series circuit, right? Here we have an amount of electrical energy, okay, whatever it might be. Okay? And it's being generated here, produced at the source, and as it goes through, it's going to get used up in these various resistors, right? And the rule that governs it, so this was Kirchhoff's first law, okay? And his first law was called the voltage law, and it simply said that around any complete path through a circuit, the sum of the increases in electrical potential must equal the sum of the decreases. So in other words, what he says, if I have 12 volts here being generated, being produced, 12 volts will be used up as it goes around the circuit. All right, and there is something called Ohm's law, which we're going to cover in the next couple of days, which will combine resistance, current, and potential difference in a formula, and then we'll be able to determine these numbers. All right, but basically it's like a roller coaster. Roller coaster starts here, has an increase, and then all the decreases, and it ends back where it starts. Same thing here, we have an increase happening here. The amount of energy drops, and the sum of the drops has to equal the source, okay? The second question that Kirchhoff asked was, when there are multiple paths, what determines how much charge, how much current goes through each path? And this was his second law, and it was called the current law, Kirchhoff's current law. And basically, it's pretty simple. At any junction point in an electric circuit, the total electric current into the junction has to equal the total current out. All right, so simply, if he had 3 amps coming out of here, 3 amps would come into this junction, okay? 3 amps has to come out, so whether it's 2 and 1 or 1 and 2, has to be 3 amps. Okay, and then when they join back up here, if I have 2 coming in here and 1 coming here, that's 3 coming into this junction, 3 has to be coming out of the junction. Okay, so the current here and the current here will both be the same number. And it will split as it goes into the parts here. And again, Ohm's law, which is about the relationship between potential difference, resistance, and current, will explain what goes where. Okay, but the law, again, doesn't explain it. The law just says, this is what's going to happen. and now it's our job to try to explain it using formulas and experimentation. Okay, so those are what electric circuits look like and what we're going to be looking at. So again, what's going to happen is as we learn about resistance in the next couple of days, we're going to be analyzing circuits, okay, where we'll be given various pieces of information and wanting to find all the other pieces of information. That's our end goal, is to be able to find for each resistor, for each use of electrical energy, what is the potential difference being used, what is the current flowing through it, and how much resistance is there in the resistor. Okay, so those are the things that we are going to do. All right, we're going to leave it at that for today, nice and short and simple. And tomorrow we'll get into resistance and what's called Ohm's law and a resistor formula that will give us some questions to do tomorrow. So have a great day and we'll see you tomorrow.